G'day folks, this is one of the units I picked up today. It's a Fujitsu mini split condenser. I don't have the indoor unit for it, but this is based on the N807 chassis. It's an AOT17RNA. Was it 1.53 kilos of R22. Doesn't actually say output power, but probably used to be written somewhere. Was installed and serviced by Coastline Plumbing and Air Specialists. Yeah. It's a pretty tough old unit. I think they have Bristol or Tecumseh compressors in them. Decent fan motor. I'll open her up and check out the compressor with the multimeter and see what's going on. They've already condemned one of the other units. I got a Mitsubishi. That one's short to earth on all pins. I mean, it's absolutely dead. But this one here, I'll have a look. Yeah, that Mitsubishi there's scrap. It's completely dead. That's a Fujitsu inverter. Don't know if that's alright or not. And this thing here is made in Korea, often badged as an LG, but this one's been rebadged as Kelvinator. Still the same thing, generic Korean junk. It's got oil all the way down the front. Looks like it's been weeping out from under this cover, so it's probably taken a dump a while ago. I'm betting there's no gas or oil left in it. Okay, well these units are pretty simple inside. The fan motors are a generic single spindle type. I see these in everything. Even window units have a double spindle version, like the very angry noisy one you'll probably see soon. Coils aren't too badly dirty either, nor corroded. And the run cap to the fan, and reversing valve. There's no contactors or other crap inside this unit. They're all in the indoor unit. A bit of a kink in that, but probably still alright. I know it's got gas in it. I checked the valve and it sort of blew oil all over me. But that is a rotary compressor, not a old Tecumseh or Bristol reciprocating compressor. Yeah, I'm not sure what type that is, but it can stay in there until I pull these off and ohm it. Just find out if it's alright. I mean, if the indoor unit for this died, then this condensing unit will be perfect. And if they pumped it down, then it'll still have a full refrigerant charge in it. I know it has refrigerant in it, but how much I don't know. So this might be useful, because I have a Dakin air handler, like one of the in-ceiling ducted types, which needs a decent sized condensing unit. I was hoping of using a Mitsubishi that's out there, roughly the same size, but this one was full of electronic controls which were damaged, so I ripped them out and would have to make a manual control panel either way. But if I can use the Fujitsu instead of this old heap of crap, that'd be even better. Hell, I'll get my uncle to recover the refrigerant from that good Mitsubishi and use it to top this one up. I get free refrigerant recovery, thankfully, and favours in return for good usable refrigerant. This is valuable. Refrigerant's valuable. The only stuff worth wasting is full of burnt out compressor acids and stuff. Nobody wants to recover that stuff. I mean nobody. I've got units sitting out the back that have been there for 6 months because nobody wants to recover them. Okay, well here's the part you'll find interesting. This is how you ohm a single phase compressor on one of these mini splits, or any single phase compressor to that matter, whether it's in a window unit, a mini split condenser, or whatever, a fridge. This should give you an idea on what to do. Now, rule of thumb, there's a bit of an industry standard to the colour coding on some of these units. Some of the cheaper Chinese ones use different coloured wires. You'll find blue, you'll find pink, and other different things, but rule of thumb is black will be common, which is your neutral from your main supply on the terminal strip. Run is white. Run is going to reversing valve on here, it's going to the fan, and it's going to here. That should be active on the terminal strip. I can't remember how they wired this one. That should be active on the terminal strip, going to the capacitor and run to the compressor, which is this second wire here. And start goes through the capacitor start windings on these are either designed to be energized momentarily via a potential relay, or they have to run through a run capacitor, otherwise they will burn. It takes a while to burn them, but they will burn if you do not use a run cap or a potential relay and energize them momentarily. Alright, let's look at ohming this thing. The procedure for single phase compressors is to go from common to start and then write your value down, common to run, then write that value down, then run to start and write that value down. Then you add the two together, the common to start, common to run, and it should equal run to start, or within plus or minus point something or other. Like, you can get a bit of leeway in it, but if your readings are adverse or going from one of the windings to ground, your compressor is definitely stuffed. Alright, let's go common to negative, just for the hell of it. We're not earthing out, so the compressor's alright there. Now let's go common to run. 1.3, yeah, I'll call that 1.3 ohms. That's common to run. So 1.3 ohms. Let's stick that back on. Common to start. 4.1. Yeah. So 4.1 plus 1.3 should equal 5.4, which is what we're aiming for. 5.4. So let's take that off. Take that off common. Stick that on there. And just start. You have to trace it back from the compressor. We've got three little wires going through a conduit, so that is going down to the compressor. 5.21, within spec. You're 0.2 out, which isn't much. And silence that. Yeah. You can use ohms, you can use continuity, whatever. As long as you can read normal ohms and fraction. So, yeah, 5.2. That's within spec. So yeah, I'd say this compressor is just fine. If you like 4 point something or 2 or something really silly like that, then you'd definitely be out. But as long as you're within these common to start and common to run added together on your run to start, 0.2, you're pretty much right. Plus or minus point something. Plus or minus 1 ohm or 2 ohms, you're bad. Yeah, so I'd put this condensing unit in a good bill of health electrically. Mechanically, there isn't a lot that goes wrong with rotary compressors. I've never seen one break a vane spring or anything silly like that. So yeah, I'd say this one's a goer. The indoor unit must have failed. And we'll give this one a clean up one day, and thanks for watching. I'm not going to clean it tonight. Okay, I've got the unit hot wired. Something I forgot to do is actually put power to it. The terminal diagram on this actually says neutral is your normal terminal and common is active. Whereas some air conditioners I find common is neutral across the circuit diagram. But being alternating current, it doesn't actually matter. I've been able to run these things with neutral on number 2 or active on number 1. So yeah, it's a funny little thing, but really easy to understand how to wire it up, especially when you've got a diagram on the inside of the bloody access cover. And this bridge here is just so that the condensing unit fan runs. You can choose, the indoor unit normally chooses whether to run the fan or not, depending on whether it's defrosting or building head pressure or whatever. My more modern version of this, which is running at the moment, cycles the fan on and off, and it's the indoor unit doing it, not the outdoor one. That's why they have a special terminal for it. So let's plug the power in and see what happens. Alright, short run, while it's still, the valves are still closed and nothing's connected to it. The suction line accumulator will go into vacuum pretty quick, but it won't actually hurt it. Pressure will bleed back through it after I stop it. Beautiful. Doing just fine. And your pressure bleeding back through to the low pressure side. Now it's done everything it's supposed to, I think. Unless the reversing valve's stuck, but that's something you find out the hard way when you connect it up to an evaporator. And that's what that Dakin split air handler's for. Look forward to a video for that one. Thanks for watching.